As anyone who builds valved pulsejet engines will tell you, one of the hardest things to do is to build a good reed valve. Now this is a petal valve out of a model size pulsejet engine. It consists of a whole lot of little petals, as you can see, and some gaps. So these petals, when the air pressure inside the engine changes, can flex backwards and forwards, allowing fresh air to come in but stopping the hot exhaust gases from rushing out when the engine fires. Now, making such a valve can be quite difficult because you can't just take a piece of good old spring steel like this and cut around it with your snips or your tin snips or your shears, because what will happen is that it will crack. You'll get little cracks set up, it'll bend and twist, and when you've finally got your valve out of the sheet of metal, it will be all bent and distorted and it will not work. So you need some way to cut this that doesn't deform the metal and doesn't cause little micro cracks to form along the edge so that it fails very early on in the engine's life. Now, if you're doing it in quantity, you can use a laser, you can use abrasive water cutter, you can use EDM. There's a whole lot of expensive and complicated techniques you can use, but today I'm going to show you how to do it using an electrochemical etch system. That sounds complicated too, but you will not believe just how easy it is to cut stuff out of solid carbon steel using a 12-volt battery or a battery charger and some salt water. So I'm going to show you now the process for turning this into a shiny new one of those. Okay, now here's the first thing we have to do. We have to make sure that this spring steel is totally clean. Now you see it's got a patina on it. That is an oxide. That's just the oxide produced by a slight bluing process during the manufacturing. We've got to get all that oxide off. It should be shiny. It shouldn't look blue or brown. It should look silvery like steel normally does. The best way to do that is using an abrasive. I've got some wet and dry sandpaper here, which, as you can see, doesn't actually do a lot. So for that reason, I also bring into play some general kitchen cleaner, which is an abrasive cleaner, sold under a number of names, Ajax and Vim and Mr. Muscle and all sorts of things. So you bring that to bear on the whole situation, you get stuck in with a good bit of elbow grease here, you will find that that oxide layer on there will gradually come off. Now, I've just done a little bit and I'll rinse it off, show you what I mean. Now, you can see how that's starting to break through the oxide there, and so it's not brown, it's actually silver underneath. What I have to do now is just carry on and completely remove all that brown and tarnish coating, that patina on the surface, to get a nice shiny steel underneath. Because if I don't take all this off, then the paint will not stick, because I'm going to paint this. And if the paint doesn't stick, then I can't do my etching properly. Now before I paint this, I'm going to take my glasses off, because otherwise you end up with little black spots all over it. And speaking of black, that's the colour I'm using for this paint, because it gives the best contrast when you're actually doing the next step, which is scratching your pattern into the metal. So I'll give this a jolly good painting now. Okay, so now we have our painted piece of spring steel, painted both sides with this etch paint. Here's a can of this etch paint, so you can see what I'm talking about. The key words on here are etch primer, and it has to be one that's suitable for use with steel. So I've painted that. It's now nice and dry next day, and I'm now going to mark out the shape of the reed valves that I want. Now here's the template I've made. You can see it's actually made from a thicker material. This reed valve template will be put on top of the spring steel, and I'll scratch around it with a regular modelling knife. I'll show you how I do that. Little tip, use a piece of paper toweling, soft absorbent paper toweling, or a rag underneath your piece of spring steel so I don't get scratches on the back, because if you get a scratch on the back, then the electrochemical etching will make marks on the back side of your reed valves, which you don't want. Now we start the process by putting our template on the material in such a way that we're going to get as many valves as possible. I've already marked that out in the right shape to get 4 reed valves of this particular size. So now I position it and I hold it down quite firmly, because I don't want it moving once I've started scratching around the outline. And here we go, just using the tip of a very sharp modelling knife. I scratch my way through the paint around the edge of the template, and I also go down the individual lines that mark or make the petals individual and around the little edges there. So it's essential that I get a continuous line all the way around every facet of this template. It's also important that you don't forget the hole in the middle, because if you don't etch that hole in the middle, drilling it would be very, very difficult later on. So you must make sure you do that. And just a tip, if you're trying to make reed valves for an engine you already have, you can use an existing reed valve like this and scratch around that. If any of the individual petals are damaged, then just rotate it so that you're using a good petal in that position, and that will enable you to create new reed valves from old. Now here we go. Here is what I've ended up with. As you can see, the reason for using black paint is that I get a brilliant contrast with the shiny metal underneath, so I can see that I have in fact scratched all the way around it and I've covered every aspect of that reed valve. What I'll do now is I'll go ahead and make 4 other scratched reed valve patterns on this sheet of metal, so that I will in fact get 4 valves out of the one plate. So here you have it. After a little bit of hard work and careful scratching, there are 4 reed valve patterns visible on this piece of metal. Now all we have to do is etch it. Now the etching process will require us to have a plastic container, preferably a square one like this or rectangular, and a sheet of metal will act as a cathode. That goes on the negative battery supply. This is going to go in here, like so. We're going to fill this up with a solution of good old table salt, like this. See, just regular table salt, and water. Let's do a handful of salt. Give you an idea of what I think a handful looks like. A generous handful of salt goes in there. Actually, I'm going to make it 2. Yeah, why not? As cheap as beans is salt anyway. Right, so there is the salt sitting in the bottom of my container. I'll now go and fill it with water up to a level that will allow my spring steel plate to be fully immersed. The next thing we're going to need is a battery charger, or just a 12-volt battery. I've just got a little 12-volt battery charger here, $19.95 from your local department store. So I'll set that down here. It's plugged in. And you're going to need a couple of taillight bulbs from your favourite vehicle. These I think are, how many watts? It says these are 5 watt bulbs. So 2 5-watt bulbs connected in series like this with a few wires or alligator clips. Very simple. Now, here is our piece of stainless steel that I mentioned earlier. I've inserted it in, or immersed it in the water, and I'll connect that up to the negative terminal of our battery charger or our 12-volt battery. So that now has the negative wire going to it. The positive wire from the battery charger or a 12-volt battery now goes off to one side of these 2 bulbs that I've wired in series. If I touch this on the negative, the bulbs light up, as you can see. Both bulbs light up. That shows us that the current is flowing. Now, we take our spring steel with the valve pattern marked on it, and what I've done on the corner here is I've scratched away some of the paint so I can hook up a crocodile clip on here. So I'll immerse this in the solution, and it's just right, goes right to the bottom. Just enough left on the top here for me to hook my crocodile lead onto, which I will do now. In fact, I'll take it out. It's easier to hook it on when it's not actually sitting in the water. Should make a good connection, I hope. And I'll drop this back into the solution. When I do that, you can see that the light bulbs here, hope you can see, have actually become illuminated. Now I'm going to remove the plate, our cathode plate, the negative plate, from the bath. And I've disconnected the crocodile clip here because we don't want any sparks and so forth. So I can now also remove the valve plate. And here we are. You notice the valve plate is covered in kind of a crystalline stuff. This is the metal crystal. This is the salts that are produced when the metal is pulled out of solution. And also you'll notice here that the back hasn't been etched, but these valves are now just able to be pulled out of the plate. And what I do now is I'll go and pull out all these valves and we'll have a look at how they look close up. Now I will take off the black paint using a solvent. So here is the final product, the finished reed valve after being pulled out of that sheet following our chemical etching, our electrochemical etching, and having the paint removed. Now you can see that's quite a nice little valve. The individual petals are free to move, there's good gaps, it's nice, it's really a good piece of metal. So if you want to make your own reed valve, it's quite practical to do so, and you can do it with quite a bit of precision if you use that electrochemical etching technique I've just shown you.